Sam Feifel. I'm the editor of SPAR Point Group, and I want to welcome you all to our webinar here today. We appreciate everybody showing up, and we're excited about the content that we have here for you coming up. From the outset, I do have to let you know that I'm in some somewhat changed circumstances in that I'm covering the Trimble Dimensions show this week, and so I am conducting this webinar from sunny Las Vegas. I apologize in advance if there are some Las Vegas sounds in the background. I'm going to do my best to minimize those, but hopefully it won't be a problem. And hopefully everybody has got themselves maybe a cup of coffee and a nice comfortable chair, because we've got the solid hour of a webinar here for you on scanning and modeling large petroleum facilities in hazardous conditions. And just first, tell you what we're going to be talking about here. We've got quite a bit of content. We're going to be jamming it all into this hour, so we're going to keep our pace up and make sure that we cover it all. And as we're doing that, I just want to let you know how you can interact with us. There are two ways to sort of talk to us here on the webinar. In the first is the chat box, and the chat box is in the middle of your right hand of your screen there. And the chat box is really it's best used for troubleshooting any sort of technical issues you might be having. You see when you pull down that little bar there that you can chat directly to Diversified Business Communications, and that is our web fulfillment person, Nicole. And if you're having any issues in terms of sound or logging in or have any technical questions, chat to her and she will get right on helping you out. Now that we have the Q&A box, what we have is that if you have questions for our panelists or questions for me that you think you would like answered during the course of the webinar, that you put your questions right there in the Q&A box. And the reason for that is because we can answer those questions, and the answer will be public, and also the questions will be saved for when this is put up as a recording later on. So it's really helpful if you use that Q&A box in the lower right-hand corner. You might have to drop an arrow down to get it to show up, but it's in the right-hand corner, and that's definitely the best way to interact with us and ask us questions. The webinar is being recorded, and you will receive a direct link and an email following the event. Usually it takes about 48 hours, 2 or 3 days. So don't let that. If there's anything you missed, you can absolutely go back and check it out later on. So move on to introduce our presenters here. They're going to have to unmute themselves. But first we have Robert. How you doing, Robert?
Thank you. I'll just run a quick intro. So, hello everyone. I'm Robert Greenhalgh. I'm the 3D Scanning and Survey Department of Oil and Gas, based in Esbjerg, Denmark. My background in laser scanning was started at ZNF in 2007 from a computer vision background, site scanning experience, plus CAD and modeling training and operational experience. At the moment, working to the models into PS, Smart Plant and Navisworks.
Thank you. And next up we have Rajesh. Rajesh, you there?
Yes, hi, good morning, everyone. My name is Rajesh Guru, and I'm the CEO of Cardiac Support Limited, which is a small company located here in Trinidad and Tobago. I'm involved in the laser scanning business since 2007 and specialize mainly in oil and gas sector. We also have an authorized training center for Hazardous, so I'm an instructor here. My background is in mechanical engineering and petroleum engineering, and I've been in these fields since 2001.
Great. Thanks, Rajesh. And finally, we have Kevin Williams. He is Chief Scientist at ClearEdge. We'd like to thank ClearEdge for sponsoring the event today. Kevin, how are you doing?
I'm doing pretty good, though. I must admit, jealous of you and your location, because I'm not in sunny Virginia right now. It's pretty cold and overcast. So I've been working with point clouds for about 12 years now. Started working with airborne LiDAR data, and in the 2006 time frame, started working with terrestrial ground-based laser scanners. And it's an incredibly exciting, fun field to be in. I think the sky is the limit in terms of the potential for this technology that we're playing with these days with 3D point clouds. So it's a great field to be in.
I absolutely agree. Thanks for that. And let's see here. It's time to move on and keep it going. And just goals that we have for today. We're really going to be focusing on specific challenges of working in the oil and gas environment, often offshore. I have to tell very many of you attendees that that kind of environment, it's not squeaky clean all the time, and the weather isn't always great, and there's certain challenges that are really specific to that, and we're going to be covering that, and then also talking about some of the technologies that can speed things up, make things safer, make it so that people maybe are spending a little bit less time in those hazardous environments, giving them a leg up, and making sure that we're doing things as efficiently and taking advantage of the technology as well as possible. And one of the reasons that we're focusing on oil and gas is because it has really become an application for laser scanning and for 3D data capture in general. And the reason is that I don't think to tell anybody that demand for oil and gas is increasing, and unfortunately the supply is not infinite. And so we now have firms that are drilling the Arctic Ocean. We have firms that are drilling in much deeper water than they were. These things, the moat you get, the more difficult it is to get to the platform, the more time-consuming and costly that is. And it's really something where laser scanning offers a lot of advantages, especially since the equipment is aging. I found this number from Reuters. The average age of the 450 drilling rigs around the world is 24 years old. So you can think about how things need to be replaced. The as-built documentation is unlikely to be completely accurate. We really use laser scanning to help us understand the environment and be better designers and operate these large pieces of machinery much better. And in general, the sort of sphere for laser scanning is improving, so it's much more likely that people are going to take this leap. And if a firm is servicing oil and gas, they're going to be asking you about laser scanning because their design software, Autodesk or Bentley or whatever it happens to be, they've all invested in point cloud technology, and they're all pushing that back down the pipeline. And they'll have laser scanners. I'm here at the Dimensions conference where Trimble has unveiled their TX5, which is their OEM version of the FaroFocus 3D. And I tell you, there's a great deal of interest in this device, and you can expect to see them out in the field much more and more often. So it's really important that we understand the technology and be ready for it and have a plan for it. And I'm going to pass the ball over here to Robert now, and Robert's going to tell you about his experiences, and then we'll take over after him. So, Robert, it is yours. Take it away.
Okay, so what we'll look at is a little background on the company, so oil and gas, and look at a sample project, something that we're doing, and how we've worked with ClearEdge and the outcomes we've had there with the new version 4. So, Rambo Gas, we're a multidisciplinary engineering company with a strong presence in Northern Europe, predominantly Denmark, Norway and Germany, and also the Middle East, based in Qatar and also Abu Dhabi. In-house survey teams based in Esbjerg and Doha, with Maersk, Dung, Hess, etc. We have 40 staff providing 3 survey and data support to the engineering and management sides of the business. So that's both site teams going out and capturing the data, the processing to get the correct deliverables, and the support to the engineers so they get the maximum benefit from those deliverables. The equipment we use, we have 5 ZNF images, the 5006, 5010, and we're adding the 5010C, the inbuilt color, to delete once they're available. We have the Focus 3Ds for jobs where we need to go a helicopter in a single day trip. Ample project here, and the platform model from the jacket up to the belly deck. As you can see, have a large amount of structural steel, and of course piping from it up to the process on the top side. The image to the top right, you see, is 4 platforms in a particular field. Below that, we have one of the kits at the water level, showing fenders lower structure. The models we deliver are layered by use, so into press lines, separated on different layers to make it easier for the end user to work with these, and also mission status is logged, so items which are due to be removed can be identified so it can know what space will be available in the future. Models allow us to then do new designs alongside previous and the future situations and conditions. The platforms have, as Sam's alluded to, their own particular operation. They're very congested internal areas, so space is absolutely at a premium, and new piping and equipment must be fitted in at first time, otherwise the cost gets very high. So with space at a premium, the accurate models are essential for these redesign projects. Modifications as part of the 5 cycle mean that we pass model around so engineers have accurate data code on in the project. We did a precise tie-in to the piping engineers to connect new spools and equipment, and they'll get a fit first time once it gets to site. Working in these areas for the site capture, we found that the swivel or twist and turn targets, also targets, and efficient targeting. In a lot of rooms we have access platforms which need scans to be taken from, so the flat paper targets don't give sufficient versatility, having angle to the in all of these conditions. The survey that we work with, we typically do a 60 to 70% target coverage, and then with the LFM register package to complete the target network using the bundle adjust. So a bundle adjustment completes the target network, so we get full coverage without having the full survey, which adds more than is available in these conditions. One of the challenges that we have is the weather. As you can see in the picture, it can be inclement out in the North Sea. So in the external areas, in a strong prevailing wind, this can actually stop due to the force of the wind on the unit. So the magnetic drives don't have to turn the scanner in these conditions. In we found the mechanical drive units can be more practical. We don't have any downtime due to that. The case study I'd like to look at for the ClearEdge 4 software. A plant room on a North Sea platform required piping to be extracted for a review and then redesign. The piping connection positions, so these were the bolted flange positions, and the connecting faces were required for the tie-in to new designs. Pipe fittings were to be used on the ANSI standard, and modelling for this with the older methods we would use with manual pipe extraction and fitting would take 3 hours modelling, and we just down to 15 hours using the ClearEdge 4, so that's a 75% reduction. To complete the particular area, took 20 scans with the 5010. This was a floor level plus 2 access platforms for upper valves and instruments. You see the image there, the point cloud with the various scan positions. It is out of Edgewise plant itself, and green indicate each scan position. Creation we did in register, which took 1.5 hours while offshore. So we complete the registration there. If there's any missed areas, we can rebuild on the platform. Don't have another costly trip out if anything is missed. After registration was completed, we used LFM converter to batch export PTX, the registered scans, and that could be brought into Edgewise plant. We've not got the direct ZFC import, so we did have to do this additional step, but as it's a batch process, it did not add significantly to the time for a person to work here. Once the data was brought into Edgewise, the cylinders were extracted within 1 hour. We got approximately 85% of the required cylinder out within that time. After the extraction, we needed to spend time cleaning, queuing, and adding the pipe fittings. So these are the standard L's, flaps, and valves that are now within the software itself, which Kevin will show later on. So that the first 14 hours. One used the COE output to AutoCAD. Allowed us to use a solid model import to SmartPlant 3D as a 3D reference. It allowed the engineers to view and snap to existing connection points to continue with their work. So the image that you see there is the extracted and connected pipes. That's using the auto-connect feature to join up pipes within scene. We found the automatic cylinder extraction really frees the user time for the placement of the components and other deep modeling. So by moving that overhead for bringing out the cylinders, you got more to do the smart stuff like positioning the components correctly and also layering the model. So we can lay in ClearEdge itself, so we export to a 2G that has the piping separated by layer, so pre-ordered, so 10 different water systems, process systems on and off as required. Chart sheet with the listing for the different pipe diameters, allows rapid QA and all approval. And see the standardized fitted cylinders using the ASME standard, and there are several others in there already. and in QA, you've got a very good fit to the point cloud data. Flange detail, also engineers to take the correct connection position directly out of the model. So with face flanges, you have appropriate dimensioned raised face and the ring joint and other flange types. A tool that we found very useful was the demo of points about the lines. So we work through the project once a line has been made and queued and verified to be as you need it. Then you can move those points from the data set. Then clear up the scene. You can exactly what remains and what has to be done. As with cylinder fitting and the piping work here, we can use points in CAD for modelling other components, for example, steel, eye sections, etc. As we use either mod format MicroStation BSI or then server suite with the connects to or CAD or MicroStation. So I'd like to pass over to Rajesh and we'll look at
Hey,
Hi again, everyone.
Robert, run 1 second, just because, Robert, there are a couple of quick questions that's probably easier to answer now. There's that quick question there. Was AutoCAD used to convert the pipes into solid models before you imported into SmartPlant 3D?
the reason we bring it that way is because you have the laid 3 reference within SmartPlant, so turn on and off the separate layers. The reason you go through AutoCAD is that it will display as a solid model. If you bring a DGN, it displays wireframe only, so it's very unclear.
And then these are questions I think, Kevin, you're probably best to answer when you give the little demo, so I'm going to save those for you. And Rajesh, why don't you take it away for your piece here?
Hi, everyone. I'm Rajesh, and I'm the CEO here in CAD Engineering and Support. So we get into the case study. I'll just be a little bit of what we do here at CAD Engineering and Support. We're basically a pretty new company that was established in 2012, and we established to provide HTS support from the standpoint to the oil gas industry. At this point, all technology basically came from Europe or the US. So this was being a niche market where we can actually provide our services at a 100% local content. So that's the main reason we were established. And I have been an instructor for the past 7 years. So I decided to incorporate that as part of the business because it went hand in hand with the laser scanning and modeling services. We are a local Integraph ICAS dealer where we provide support and services as training for the CADWorks suite of products, Caesar, PV Elite, Fabricate, and all those other nice products that you see there. The case study, what we had to do was to scan and model, providing a 3D intelligent model of one natural gas facility here in Trinidad. So this would normally take the client between 2 to 3 months to complete using the traditional techniques of measuring tape, bulbs, laser, that kind of stuff. We would go out there with our laser scanning and complete project planning to final deliverable until 3D model in 4 days. And we used 2 field technicians. Same field guys also did the modeling, one Leica, HDS 6100, and just in targets. So not a lot of resources. The field time was pretty much 5 hours from the time we put our office to the time to our office on that day. This we did when we get to that site, or just any site you're scanning, you'd need to do a walkthrough to determine exactly where you'd like to position your scan location. Based on this position, you then stand and put your targets. You can pretty much get a field of view of all your targets. The station took pretty much 6 scans, which included the scans outside of the facility, because we wanted a topography of the site as well, a site layout. After we completed the scanning, we returned to the office where we registered our point data using the cyclone register suite, exported the unified point cloud using CG export, which could be imported directly into Edgewise, where the pipe extraction was done and was left overnight to complete. The next morning we got to the office. 2 of work was now completed. So 95% of all our piping automatically extracted by the Edgewise plant software. This really considerably saved us on time, because it would have taken us another 2 or 3 days of cyclone modeling to analyze that same data in terms of the cylinders. We completed the extraction process. Feed directly this data into Cyclone, where we build our elbows, flanges, valves, and fittings. This was using version 3.2, and of course, if we were using version 4.0, this would have left even more time, because now we could have completed all our elbows, flanges, and fittings directly in the Edgewise product, and not have to even go into the Cyclone product for modeling. The next, after going into Cyclone and completing those fittings, was to export, do a COE of that model into AutoCAD, where CADWorks is also running on that same platform. The center lines of those models to develop our CADWorks intelligent view. The facility took less than 3 days. In terms of productivity, this wasn't in terms of in our country. The plans really saved us a lot of time, over 60% in the modeling workflow. Just 2 additional days doing the CAD modeling to complete that model. A bit of the challenges that we face, or usually face, when you do some of the modeling in these facilities, touch on some of the tips and techniques to some of these problems. So some of the major problems you would face is trying to target your facility without over-targeting the facility. Also, you might end up coming about a lot of heavily congested piping, especially small bore piping that are really congested. How do you get your scanner to get out data so you don't have too many occluded points? Also, some of the facilities, especially gas facilities, you have a lot of tape, denser tape, especially on those flanges. And that's a problem, especially when you're doing dimensional control. The laying, some of the plants are pro, so the lagging is really bad. It's not on properly. That really creates some challenges for us. Also, the twisted piping, definitely, that's a bad thing. These plants are all outdoors, so it's there plays a big part in it. It's not covered. So when it rains, and of course in the Caribbean a lot here in Trinidad, that holds us back a lot. Fiber is not a problem, especially on the offshore platforms where you have a grating and a structure. The scan sometimes shut down because of high vibration. And then if it has a problem, the scanners themselves acting up and holding you back from a job. Ways that we try to combat some of these problems is we use those tilt and turn targets, as was mentioned in the previous slide. They give you a really good point of view. Using a few of them, you get them from many different locations, as opposed to the flat targets, which are restricted in this way that kind of can see them. Okay. Generally, in the field, I always tell people what you can get in terms of acquisition of data. the less time you're going to spend, because you're going to have so much data to utilize to be able to provide your model. Now, there's a benefit to this in the sense that now with EdgeWise, you have to have that much data to be able to extract your pipe. So, I mean, this can be a strong point in this case. The modeling without EdgeWise, then definitely you want to get as much data as possible so you can things in correctly. The tab there's experience in being a big part in terms of determining where to set your scan locations up. And to do mainly with to see the plant. When you're looking at a location, you're using 2 points of reference being your eyes. The one point of reference, which is the center of the laser. So you're seeing not what the laser scanner might be seeing. And you do a number of scans, you can get a feel for what you can and cannot pick up with the laser scanner. So this determines exactly how much locations you're going to have, where you position your laser scanner so you can get as much data as possible. The denser tape, traditionally, if it's not a dimensional control type job, then worry about it because that level of accuracy is not needed. If it's a dimensional control job where the exact location, the flange required, then you remove the denser tape. This the pipes the thing you can't get away from. You would need to communicate with your facility manager to determine, how much of an accuracy you really need in these type of piping, and you can vary your model to accommodate this if necessary. I found a really good solution just a couple of scans ago, where we just took a garbage bag and cover the scanner. It saves the time in terms of not having to take apart that scanner, put it in a box, and set it up again when the rain stops falling. So a very cheap but effective solution. When there are a lot of vibration, we normally tend to ask if it's scanned on time or to probably turn some of the equipment off that is not really needed. If we can close to this equipment, we tend to turn them off so it provides less vibration. One thing I didn't have on my slide here is with respect to the equipment, we always should have one backup equipment, not necessarily on site, within a couple of hours time to our platform or our site location. Some modeling challenges you normally face is having a lot of occluded regions of the point cloud. That is directly related to where you position your scanner and how much locations you're taking. With a lot of skewed piping not kind of perpendicular. People may pull piping out of a 90-degree bend, for example. So you have a 90-degree bend, create some challenges in doing. The non-standard fittings, especially older plants, you have a 400 specs or stations that you don't even know about. Also, like the shapes of objects and of the CADWorks, or most of the design software can't model these as is conditions. If pipe that is sagging, your software wants to model a straight pipe. And in reality, if you place that piping with a piece of pipe, you will be replacing with a straight pipe in any case. You're not going to replace it with a bent pipe. Important to know that the pipe bends because, especially for crews, you need to pick that data up. So your point cloud is basically the best and closest place conditions you have. Start modeling, you move away from that exact as-is condition, mainly because of the way design software is operating. So the extraction and the complete algorithm is generally use that from where you don't have enough points. The software doesn't require that many points to be able to generate a cylinder. So a lot, especially in those type locations where you might be able to get all of the piping that you think that you require. So understand what is the plant requiring. If it's not dimensional control, then we don't have to worry too much as to the exact locations of every single piece of fitting that we have in that plant. From the get away, it is just a 3D model to do our materials or for the guys in the field to work with. And that is not such a big issue. So we can deal with them to tape and the rough-fit piping and the bend piping and all of that stuff. The thing about the edgewise plant is you can put in a lot of non-standard fittings in there, so it greatly improves and enhances your productivity time in terms of the older plant. Because these new tools now model much faster, we don't have to sacrifice our accuracy of speed because it's so much better and much quicker. And it reduces a lot in terms of getting a durable, much quicker to the plant and much more accurate as well. So with that, hand you over to Kevin.
Hey,
thank you,
Kevin.
Josh.
Hey, Kevin, getting that wrapped up. It looks like there's just a couple of quick questions that maybe Rajesh could handle best right now. And first of all, there's a new one on me too, Rajesh. What is denso tape?
The fiber is a very sticky tape that is used on those flanges. Some people use it to, when we put it in, if you have very small leaks, it prevents that from escaping into the atmosphere. It's a sticky, difficult tape to work with.
And the other question I think that would be good is, you talked about the amount of time that you needed for the scanning. I think it was 4 hours in the field, was it? What quality or what resolution were you scanning at to get that time?
We have high resolution. A scan typically takes us 3 minutes on that high resolution to look at.
Okay, excellent. All right, why don't you take it away, Kevin, because I think a lot of the technical questions are going to be answered by you.
Thanks, Sam. The first couple of versions of Edgewise Plant were great time-saving tools. They did really well. They automatically extracted pipes and elbows, but they were fairly limited in the scope of what they could model. So 4.0 is a full end-to-end solution for creating pipe models. In this version, we filled really all the remaining gaps in the workflow process. And we think we did it with very fast, very efficient and accurate tools that really ought to make pipe modeling a whole lot more pleasant task going forward. It should be a lot more cost efficient than used to with some of the older technology. This next slide shows some of the major new features that we added to Edgewise Plant 4.0. The first and most obvious thing is we drew out our old point cloud visualization engine. If you guys had used an older version, it was really meant to just kind of process through a bunch of data and create pipes automatically. But with these new tools, we really needed to have a good quality point cloud visualization engine. So the current version, we've tested it with up to 10 billion points. That's just the largest data set that we have, but in theory, its only limitation is the size of your hard drive. And it works really quite well. We've substantially improved the automated piping, so it pulls even more pipe than older versions. We have really cool new QA tools, and we think we've got the QA process about as possible now. You can QA 1,000 pipes in an hour if you know what to look for. It's a really quick and very thorough way to make sure that all of your pipes are perfect. We've got driven valves, flanges, reducers, eccentric, concentric. So we've built out a set of specs, and all of the components are based on those specs, and that's fully editable. So you can, if you're working with the spec, you can clearly build your own spec and use that to create components. We have a demolition tool, which a lot of people have expressed a lot of interest in. We've had a lot of requests for that. What it essentially does is it finds all the points associated with pipe run, and will remove them from the point cloud. So it's as if the pipe never existed. we have the ability to, well, I just talked about, to create unique specs and as well as layer standards. So we really sped that whole user interface up quite a bit. So let me get to an actual demonstration here. If I can share my screen. Here, so you should be looking at a pairwise plant. So this is actually the SPAR point cloud, but it's one that was appropriate for with the valves and flanges and everything that we can't display publicly. The data sets that we have are confidential. This will certainly do. Let me show you a couple of the neater features of the point cloud visualization engine. You can jump to any of the scans, get the data from the position that scan was. You can see we just jumped to sort of a scan, and it looks like a picture. This is called bubble view in some of the other applications out there. Jump to another one. And navigate your whole scene this way if you'd like. To 3D. And a pipe model here. This is a fairly small data set, so this took about 4 or 5 minutes to produce all here. Automated processing tools. The point cloud, we leave kind of a ghost of a point cloud now. We may not get rid of that. I'm not sure. Some people like it, some don't. But there's an overview of the that were extracted. If I zoom in on some of these, you can see and turn the point cloud, the full point cloud back on. You have it. It dives with the point cloud. One of the things that we found still wanted to improve with the last software was the QA process. So we've got some really slick tools for going through and QA single pipe now. I'm going to open up the Smart Sheet and look at the individual parts, and I'm going to go here and turn on inspection mode. All right. And if I click on one of these, essentially what the Smart Sheet, if you haven't seen it before, it gives all the information for each of these pipes. And if I click on it, it's going to jump me in the view when I'm in inspection mode to looking straight down the barrel of that pipe. So you can see the outer circle of that, and you can see all the points that were used to fit that pipe. The next one, you can see very clearly the quality of the fit of each of these pipes. And you can even start arrowing down through them and to get to one like this, where you can see there's not the that was fit was a little bit too big. You can see that the real circle ought to be here. So there's a handy little slide bar over here that you adjust on the fly, and it refits to the point cloud. And so once you're done looking at each of these pipes, so to the next one, and you see if I open up the spreadsheet, we've got an approved column over here, and every pipe that I've clicked on has checked on to yes. Now, if I actually don't approve of one of these, I can toggle it back to no. But it's a thorough way to make sure that a person has looked at every single pipe and validated it, and make sure that it was a good fit to the data. So you can really quickly, with the arrow keys on your keyboard, go through a lot of automatically extracted pipes in a very short time and make sure your data is perfect before moving on. Back to put here, and if we find an area, have an interesting area here. All right, so the flow now is to go through, make sure all of the automatically extracted pipes are correct, and then edgewise, as these guys talked about, it doesn't find all of the pipes, particularly in sparser data sets. So it has missed some of the pipe components here. So there's a missing portion of this pipe here. So there are, again, real quick and easy manual tools to go through. And you don't have to do any prior cleanup of the point cloud data. Just select a pipe and outline around it, and these new manual extraction tools are a whole lot better. The old ones would solve correctly maybe 70% of the time. Now it solves almost always correctly. So you can really go through and pull chunks of pipe. When you're extracting missed pipes, auto connect algorithm. Makes all the logical connections in the piping network. And then we can clean the pipes and standardize them. So in Edgewise 4.0, we've got a list of different standards. We now have DIN and British standards, and you can all choose the pressure rating within that standard. So I'm going to have all of my pipes default to 150 psi, and standardize all of the pipe diameters. Standardized, we can go through and start adding components. So each a bunch of valves here attached to these pipes. So let's drop in a valve C1. We have a host of different valves that you can choose from. These look like flanged gate valves. So you see one here, you see one here. One here. Actually, I'm going to need to extend this pipe a little bit to put a valve on him. All right. And then, so these are, I just roughly placed it there. Now I can set these into place very accurately against the point. So I can look at it's lining up with the boulder side. In real close, you can see that this object here is comprised of the middle, and it automatically gives you the flanges on either side as well. And you can delete those; they're individual pieces. You can also go through and there is a hand currently representing it too shortly, but we can rotate this hand wheel in here. Rotate a little bit, and you can see the hand wheel with the actual hand wheel of the valve itself. Same type of thing works with flange well. So let me go through, and I don't know if I have actual flanges around here, but I can show you real quickly what they can wise. Let's choose slip-on flange. You can just clear. And again, these are properly dimensioned flanges with raised faces, and they come in pairs. If you only want to model a single one, you can delete one of those. But most of the time, you're inserting pairs. Now, where the dimensions come from is we have a library. So on ASME, get here we've got the different sizes, the nominal sizes of pipes that are allowed. You can look at flanges, and for each of the different pressure ratings, see the different that define how that flange is rated. So everything is entirely spec-based. You can create your own specs and import your own specs. It's a very flexible system, and it keeps everything lined up and creating the correct parts. Now, one other thing, let's go back to model and sheet for this pipe. I'm going to click on the chain. See, it was defaulted to 150 psi. Now we changed that on the fly, and watch the components as I do so. So I'm going to change it to 300 psi. You can see that the components all resized and got beefier because they have to they match up with the 300 psi spec. So it's extremely dynamic, all entirely spec driven. My thing keeps hiding my controls. All right, let me one last thing. Talked about the demolition tool. I just want to show that to you real quick. I select a pipe. I'm just going to, this takes a little bit of time on longer pipes. What we can do is show all of the points that are associated with that pipe. So it went out and grabbed all the points, and you control a radius around that. So if there were any components on there, we would grab all the components as well. And so you get a point collection of everything associated with that pipe. You can go and delete those points. And this will go through and completely remove them from the database. So if I navigate now, you can see that when refreshed, there's now no pipe in the point cloud at all, as if it never existed. So it's completely removed from the point cloud. We can add it back in if that's a mistake. That's real easy to back in. So we can restore those points and choose the file that I just created. And here's our. So once you've finished creating the model with these tools, you can export to MicroStation or AutoCAD or Cyclone, and we're working. It's probably won't be in the initial release, but we're working on integration with PDMS as well. So that's the demo. Let me hand it back to. There we go. All right. It should be back to the slide deck.
And I'll get the power back here. All right, beautiful.
Okay. Here we go.
Nice work there. We're definitely in our little final row here, and I want to make sure we get some questions answered because there are quite a lot of them. That's often asked Kevin, and I want to get some feedback from Robert and Resh as well, is, how small of a pipe can you extract?
I'll take first stab at that, and I'll let the other guys, if they want to share experience on that. It's completely a factor of the quality of the data, the density of the data, and the noise in the data, as well as the noise of the pipe itself. If you have smooth pipe, perfect data, you can get quite small. For practical purposes, the software does a pretty good job down to 1 inch. You can manually extract things down to 3/4 of an actual inch fairly reliably. Not nominal 3/4 inch, but an actual 3/4 inch.
Robert, what's your experience? You're out there in the field. Were you attempting to get small pipes, and were you successful?
Within the so I showed you, there's quite a lot of fire water, which is typically very small bore, 1 inch bore, so it's maybe 30 mil outer diameter. It was getting out of those, but again, it's based on the range of these pipes from the scanner. Like Richard said, we use the high resolution, so that's the 3-minute 22-second scan. But yeah, we did have quite a lot of that taken out automatically.
And Rajesh, kind of a similar question, because we also have a question about accuracy. So, okay, it's getting the small pipes. Were you satisfied with the accuracy? Did you have any problems with accuracy with that it was fitting the pipes to the point cloud?
Not really able to get down to 1 inch. Typically, most of the plants require one above to be modeled. Anything below 1 inch, like tubing or conduit, not too critical in terms of the exact location of those. So, from the events of the plants, the software is able to extract everything that we require here.
Great. In terms of just the flow in general, I saw both of you, Robert and Rajesh, do exporting and importing, and so maybe starting with you, what's the sort of stickiest point, or where could workflow be smoothed out the best? Where's the point where you wish you didn't have to do quite so much exporting and importing, and how to make it easier?
Yeah. First thing would be the ZFC import down into ClearEdge, because handling PTX is ideal. It will take 120 megabyte ZFC and go up to 1.6 gigabytes for the same data. So, that would be the first thing that could really improve things.
What about you, Rajesh? Go ahead.
No, one of the problems. One of the things that might be nice to have in terms of the point extraction is when the edgewise product extracts the piping and you do auto snap, you see some of the piping because of how it snaps, it moves out of position slightly. It will be very helpful because, especially for those dimensional control jobs where you need to have the exact location, it may be helpful to be able to have some sort of control the piping along the length of the pipe, so you can actually move it or nudge it into place to fit those clouds correctly. So if you're doing a non-intelligent model, then that is going to suffice really good. For intelligent model, there still will be problems because that's going to model into one of those design software that can't do this. But it's going to be helpful because that's one of the problems we generally to face a lot with clients. They want to see the exact position, and we just can't get it done.
Yep, go ahead.
Just after Rajesh, there is new functionality to do that. I'll show it to you afterwards. It's pretty cool.
Okay, great. So that's great. That's excellent.
A couple more questions for you, Kevin. One of the questions is ClearEdge only for pipes? And people not know that some of the capabilities that you have in other software. So we talk about what other automatic feature extraction you're working on.
Okay. Yeah. The Edgewise plant is primarily for pipes. We also have an EP version of that, which again is focused on cylindrical objects, but and we have a building tools we are currently working hard on that we're hoping to have out in the earlier part of next year as at least a big version to some of our testers. And we're excited about that. And we also do terrain modeling. the software is quite good at automatically just extracting out all the ground surface and following the terrain up and down hills, which we have a number of people using that utility as well.
Great. You know, we really are right at our hard stop here, so I do want to get to this last slide. This is our contact information. So, you know that there are a couple of questions that we didn't have a chance to get to. You know, a lot of ground to cover here, and it wasn't possible to get all of them. But if you do have follow-up questions, you can contact one of us directly. The email should be right there on your screen. Hopefully you can see those just fine. All of us are willing and able to answer any questions that you might have. Feel free to fire those off. I just want to take this line to really thank Robert, Rajesh, and Kevin. I'm sure that the attendees had the same experience that I did. This was great stuff. I feel like I definitely learned quite a bit. Really appreciate that you guys made yourself available today. Thank you.
Thank you.
Thank you, Sam.
Thanks, everybody, for attending. Like I said, there will be a recording that will be sent out. We appreciate everybody participating and asking questions. If you don't get an email with a link to the recording, maybe Spam Filter caught it. We also post it on SPARpointgroup.com. There's a sources tab, and you can find all of our past webinars there. And more people sure would be angry with me if I didn't mention that you can also see some of this great content in person at our SPAR Europe event, which is in The Hague next week. I'll be flying from Las Vegas to the Netherlands in a couple of days. And, you know, if you'd like to be there, we would certainly love to see you. Thanks once more to ClearEdge for sponsoring the webinar. We really do appreciate that. And I think now it is time to go hit the casino. So hopefully you all have a great rest of the day. And thank you all so much for being here. We'll talk to you next time.